Greetings students, Mr. Torres here. I'm going to give a demonstration / tutorial of how we can create a program that's going to calculate compound interest. Hopefully you guys have learned about the power of compound interest, and this will help you see how even a small initial investment can turn into a lot of money if you give it enough time. So we're going to write a small program, and here are the goals of the program. It should take 3 inputs from the user. It should take their, first of all, their initial investment. So how much did they invest? And it should also take their interest rate. So they'll have to know what their interest rate is in order to calculate how much money their investment will accrue. And third of all, we need to know how much time that their investment will need to mature, because of course it'll grow over time, so we want to know the value after a specific number of years. Okay, and this interest rate is the same yearly percentage, just to make sure that the formula is going to work, because as you hopefully know, the formula for a compound interest calculated yearly is that A, or the final amount, is going to be equal to the principal investment times 1 plus the 1 plus the rate, which we will call R, divided by 100, raised to the power of the time, which is T. So for those of you who are new to programming, just letting you know, these are just comments. This is not the actual code. We haven't written it yet. But this is what our code should do when we're finished. It should take those 3 inputs, and then it should output the value of the investment. So let's get started. The first thing we'll want to get from the user, like I said, is the initial investment. So we're going to create a variable. Var is the command used to create a variable. And we're going to call this one P, because this is our principal investment, the initial amount. Prompt is the code to get the value from the user. And then the message to display it is, we'll say to the user, enter your principal initial investment. Okay, let's just test our code, make sure it's running. There's our message, and we see we can enter a number here. Of course, it doesn't do anything with that number quite yet. All right, we still have 2 more inputs to get. So we want our rate as well. So we're going to prompt the user for their rate. Enter your yearly interest rate as a percentage. Now we want to make sure they enter it as a percentage, because we don't want them to enter 0.08, because of course our program is going to do that calculating for them. So let's lastly ask for the time to mature, which we'll call T. So we'll prompt the user, enter the number of years. Okay, so now we should have 3 prompts when we run our code. First, enter your principal investment, let's say 1,000. Enter your yearly interest rate as a percentage, let's say 8%. And let's enter the number of years, let's say 10. Okay, so our code is successfully collecting the values from the user. So now we have to do the calculation. All right, and we're going to create a new variable called A, which is going to store the actual value of our investment. All right, so var A equals, this is where we're going to start doing the calculating, P times, all right, and we're going to do 1 plus our R, our rate, divided by 100. Now you may be tempted to just use the caret symbol, but in programming it's a little bit different. We can't just use that. There's no exponent symbol in programming. Instead, we have to use a special function from the math class, math.pow, which stands for power. And the first argument here is going to be the expression that we want to raise to a certain power. So there's our expression, and we add a comma. And the second argument is going to be what power we want to raise it to. If we look back to our formula, the power is t. That's the amount of time that our investment has to mature. So I know that looks a little bit different than a traditional math formula, but that's how it looks in computer science. So we're going to take 1 plus r divided by 100 and raise that to the power of t. And we're multiplying that whole thing by the principal, which of course is the formula. So let's run this. Make sure I have no errors. Principal investment, $1,000. Yearly interest rate, 8. Number of years, let's say 10. Okay, code execution successful. So there's no errors, but it didn't display the value. So we've calculated the value, but we still need to display it to the user. The command to print something to the console or the window is console.log. And then we type our message in quotes. We'll say the value of your investment is, and then we're going to do this fancy trick called concatenation, because we want to also show, in addition to this string of characters here, we want to also show the variable, which is a. And then we also maybe want to add the word dollars at the end there. So now, after we calculate the value, it should display it. So my principal investment is maybe $1,500. My interest rate is 8%. My number of years is 10. And now you will see it outputs the value of your investment is, okay, so that's what we type down here, plus, it's not adding, it's just inserting it into the string of characters here, A, and the value of A is $3,238.39. Okay, so we're almost done, but obviously you can't it doesn't really mean much to have decimals beyond the second place, because this is a dollar amount and we have only hundreds to use in our currency. So what we need to do is basically round this value. Before we print it, we want to round this value to the nearest 2 decimal places. So I believe, if I recall correctly, it is going to be a.toFixed. So the variable a comes with a function called toFixed, which truncates it or rounds it to 2 decimal places. So that should fix it. Let's see. 1,500, 8%, 10 years. And now we have it. Although maybe I want to add a cash symbol there. Let's run it one more time. 8, 10. And I guess I don't need the dollars there if I have the $sign. And there we have it, folks. So that is how you write a brief program that will help take a initial investment, a yearly percentage rate, and an amount of time, and output the value of your investment. So this can be fun for students to see how this stuff is calculated, and even have a program that they can use to test their investments just to see how much their stuff can grow. So we can see how the effective time, how time can affect the output as well, substantially. So let's maybe run it twice with same principal investments, but we'll just first do maybe 20 years with an investment of $18,005 at 8%. And we'll see it only accrues to $86,000. But let's maybe wait 5 more years and let's see how much we can get. So we'll go to 2,500 years. I'm sorry, 25 years. So 18,500 at 8% again. Let's try 25 years, and we can see we have added tens of thousands of dollars to our investment. So hopefully this demonstrates to you guys how valuable time can be with a magic thing called compound interest.